for the introduction. Thank you very much for having me here. As you said, I will be talking about Quarkus and hopefully doing a demo, showing it really quickly on how we can use it with Kubernetes. Let's get to the presentation part first. Let's see. Hopefully you can all see my screen.
Not yet.
Not yet. Okay, so let me try this. How about now?
Yep.
Excellent. Excellent. Let's get to start out with slides. So as you said, we'll be talking about Quarkus today. So this is more of an introductory talk to Quarkus, like the general ideas behind it and a short demo of how you can use it. And then later on, I'm pretty sure Stuart, also from Red Hat, also part of the core Quarkus team, has a more in-depth talk about Quarkus. So if you like what you see here, please stick around to see Stuart as well. Let's get the boring stuff out of the way. Who am I? My name is Georgios Andrianakis, or George, basically. I'm a software engineer here at Red Hat. I work on Quarkus and Spring stuff, so I'm nominally part of the Spring team here at Red Hat, but now I usually do Quarkus most of the time, but Quarkus with Spring as well, and Kubernetes and stuff like that. I'm based in Athens, Greece, but as you might have guessed from my English accent, I also have American origins. But anyway, so apart from my work here at Red Hat, I'm also a speaker at various conferences when we still had physical conferences, and now with digital conferences as well, like this excellent effort. And I'm also a co-organizer at the Athens Kubernetes meetup, which is also digital these days. So let's get started. What is Quarkus basically, right? So when we're talking about Quarkus, and if you've never heard of it, what is it? So Quarkus is an open source stack that you can use to write enterprise grade Java applications. So what does that actually mean? It means that you can use Quarkus in order to write applications that target these new, let's say, modern architectures that we see now that most even large shops are adopting. So cloud native architectures, microservices is a very big focus, and even serverless as well. What this means is basically that although you can use Quarkus to write like any sort of Java application, right? Or you could use use Quarkus to write your traditional huge monolithic application, and it will perform excellently. It just means that by the focus of the Quarkus team and all our engineering efforts is basically to try to solve problems that arise from this cloud native and microservices oriented world. So that's what we're saying by that it's use or that we target cloud native and microservices and serverless. So why in this world, in this let's say containerized cloud native world, why do we need something like Quarkus? Like what's the big gap that that Quarkus fills that like these older, more traditional Java frameworks or stacks have a hard time with? And the first answer to this is that basically when in this cloud native world, when we're talking about microservices and stuff, we generally the big idea is that we're taking a what we used to do with a big monolithic application. So you had a single application that was huge, had all the functionality, got deployed not very often. And what you're doing is you're breaking it down into these smaller components, which in microservices could be like tens of microservices. If we're talking about serverless and functions, you could get into the hundreds of components. And why is that a problem for Java applications in the cloud? Well, the problem is very eloquently described by this slide, right? The big problem with Java in very small and very constrained environments is that it takes up a lot of memory. And when I'm saying memory, I mean not only the memory that us as developers use to actually write our application to get stuff done, but memory that is hidden from developers that the JVM itself needs in order to perform at the levels, at the awesome performance levels that it has. So taking a step back, what this means is that in when Java was created and like progressed through the years, the let's say the emphasis was always on providing maximum throughput, so maximum performance for the application at the expense of memory. But when we look back at the slide here, in the traditional applications, when you had a big application, the part of the memory that we see on the left, which is this matter space, code, internal, direct, and other stuff, so not the heap memory, was actually hidden. It was actually a very small part of the whole memory that this big old monolithic application took up. But when we're taking this application and we're breaking it into smaller parts, like microservices or even functions, then the heap is it takes up a much less percentage of memory than all the other parts of internal memory that JVM uses. What that means is that in, let's say, really simple terms, if you want to run, let's say, 10 microservices, 10 microservices for a for an architecture, 10 Java microservices that, let's say, you want to constrain to 512 megabyte RAM each, right? If your JVM just to operate is taking up, let's say, 200, 250, 300 megabyte of that 512 megabyte of total RAM that you want to allocate to the container, then you, as a developer, you're only left with like 200 megabyte of RAM in order to useful RAM in order to execute the application, and that becomes a problem. So you're wasting a lot of in quote unquote wasting. You're wasting a lot of memory just for the JVM to be able to perform at the levels it needs. And of course, in containers, you're not looking at RAMs of RAM sizes of like 4, 8, 12, 16 gigabyte. Usually, you're looking at really small constrained environments, maybe even like 512 megabyte or a gigabyte. So this percentage of memory that's used by the JVM itself becomes very important. And if you try to use like older stacks like Wildfly or Spring Boot or things like that in these very constrained environments, the folks that have tried this, we have all run into problems, and that's like one of the very big reasons Quarkus exists, is to address this problem in the Java space. Based on what I said earlier about, so if we go back and think about, like, let's say the state of Java in 2015, for example, when Quarkus wasn't around, then you have the notion of like people were trying to run like Wildfly or Spring Boot or whatever else in containers, and they were seeing that, yeah, on a single node, well, let's say a single Kubernetes node, they could only run like, let's say, four instances of a Java application. Whereas if they move to like Node.js, then they could run the double amount, maybe more, because Node.js took up less memory. So the idea with Quarkus is that we do a lot of work in order to cut down that memory as much as possible, so you can run a lot more. You can pack a lot more instances of an application or microservices into the same node. So for the same amount of RAM, you can have like possibly double the number or maybe more, depending on how you use a Quarkus application. So at the extreme level, where we're using Quarkus with GraalVM's native image compilation, so when we compile a Java application down to a native binary using GraalVM, then the memory should be comparable a little higher, but definitely comparable to what you would get with a Go application. And that's very, very important when you're trying to utilize a Kubernetes or whatever other cluster you have, because you can't scale. It's hard to scale these nodes up to memory as much as possible. So you want to pack as many instances of an application in there. So moving along, what's with the name? So why do we call it Quarkus? We call it Quarkus because it's let's say a joining of two things, of quark, which is the elementary particle, and us, which we like to say is the hardest thing in computer science. Okay, so that's like we talked a little about how why Quarkus exists, like why we thought that at this time, like the times we live in the microservice where everything is microservices and cloud native, really needed a shift, really needed something different. So that we described like what the big problem is that we're trying to address with Quarkus. But now let's see what are the 4 defining characteristics of Quarkus. What do we see that differentiates Quarkus from most of the other Java stacks out there? So first of all, we have 4 benefits, right? And the first and foremost benefit that we think is super important for all our users is that we really want to bring developer joy to people that use Quarkus to develop their applications. What does that mean? What does that mean? It means that first of all, the framework is super fast. So you start up very, very fast. You don't have to wait around forever to get your changes to see the changes. Second, then you make changes in your IDE or your lightweight editor or whatever you're using. And then those changes are immediately reflected onto your screen. We'll see that in the demo. And what that means is that you don't have to go through all the hassle of recompiling, redeploying, blah, blah, blah. All that stuff just works. Then we have this notion that there's like this single way to configure everything. So you have a single applications properties with everything documented, all these properties documented really great. So the framework really assists you when needed and gets out of the way as much as possible. So the focus here is to make you as users as productive as possible and not have to drown in silly details. Oh, and another excellent benefit of this developer joy thing is that it makes compiling a Java application down to a native binary super easy. So it's just one command, and Quarkus takes care of all the rest. So for folks who have tried GraalVM like without Quarkus, then you will know that it's really hard to get GraalVM to compile an application down to a native binary because there's so much stuff that needs to happen. So Quarkus has all that information and can do this transformation in a hassle-free manner. So it leaves you joyous. Developer joy in cloud native, right? So we talked about like how it gets out of the framework, gets out of the way when you're developing an application, but it also means that because we're living in this cloud native and Kubernetes oriented world, that we want to bring that developer joy to the next level as well, right? So it makes it super easy, as we'll hopefully have time to see in the demo, to take your application and deploy it to a Kubernetes cluster with like almost zero effort. You'll see what I'll do. Also execute like one command, and then the thing will get deployed. And of course, it integrates with all these awesome cloud native oriented libraries and frameworks to make to be able to take advantage of all these services that cloud providers have for you. So like serverless integration or like metrics, health checks, all that cool stuff. SSO just work out of the box. So the second very important benefit, and it's basically how I started to talk about what problems Quarkus is trying to address, is that what we call Quarkus is what we call supersonic and subatomic Java. Supersonic means that it starts really fast, and it has very very good throughput to serve your application, to serve as many requests as possible. And subatomic means that it consumes very little memory. So what we have here is a slide of we're comparing Quarkus, let's say in the middle, the Quarkus in the JVM mode in the middle versus a more traditional, like older style framework. And this is for like a simple hello world application. And we'll see that we see in the slide that the Quarkus application takes about half the memory of the traditional application. And if we want to take it to the next level, if we see on the left part of the slide here, is that when you utilize Quarkus and GraalVM and compile down to native binary, then this hello world application can take up as little as like 19 megabyte of RAM. These numbers, if you try them, might be a little different for you. It really depends on how many cores you have on your machine and what version of the JVM you're running. But this is like a reference, like for us, the numbers you see here are a reference for, I think, Java 11 and a single core machine. And we're talking about single core because, okay, on our laptops and desktops, we might have like 4, 8, 16 cores. But when we're deploying to Kubernetes, you usually have access to only like 1 core, maybe 2 cores, because your containers are constrained to that many resources. If we take a slightly more realistic example here, and to show you how supersonic and subatomic Quarkus is, in the middle, we see that this application is like a CRUD application, right? So it uses Hibernate to talk to a relational database and return the results and serialize them with a JSON framework, like a JSON library like Jackson. In this example, Quarkus takes about like 145 megabyte RAM, again for Java 11 in a single core. And the more traditional, like older framework that I'll leave unnamed here, would take about like 210 megabytes. So it's roughly, Quarkus uses roughly like maybe 60% of this of what older frameworks would use. And again, because Quarkus supports everything, compiling the whole ecosystem, the whole Quarkus ecosystem is compilable down to native binary when we use GraalVM. We can take that same application, compile it down to the native image, and it would take about like 35 megabyte. So that's really amazing for cloud native, for a fully capable Java enterprise stack, to be able to have numbers like this. And the second part, where we talk about how fast Quarkus starts, the same examples again. The hello world is resting on top, and the Hibernate application on the bottom. The Quarkus application will start definitely in under a second. On my machine, it will start in way less than a second for this application, whereas a traditional stack might take like, we're talking about 4 seconds here. And I have to emphasize that this number is time to first response. So it doesn't really, we don't really, as a developer, you don't really care about what the framework says the startup time is, right? Because it could be cheating or something like that. What actually matters is how quick the framework will respond to your first request. So you don't want your framework to say like, okay, I started in 1 second, but then you press F5 on your browser and it takes another 2 or 3 seconds to load. So this is the time to first response. So by the time the framework starts and can actually respond to the first request it gets. So Quarkus in JVM mode, about a second, probably less. And if you take that down to the native binary, so with GraalVM, then we're talking like tens of milliseconds. I mean, it's really, it's amazingly fast. And again, with the CRUD application, Quarkus will definitely start in less than 2 seconds. A traditional stack could take up to 10 seconds, maybe. But even with the GraalVM, Quarkus and GraalVM, again, tens of milliseconds. So these are numbers that are really important. I mean, if you're deploying your application multiple times per day, or if you're utilizing something like a serverless where you're paying for the actual time that your application is up, these numbers are very important. And also they're important for your day-to-day work, right? So when you make a change, you want that change to be reflected very fast. You don't want to wait around 10 seconds for your application to come back up. And I'll show you later on in a few more slides, we'll talk about why Quarkus has these excellent numbers in a very, very high level. But now we're going to move on to the further benefit, for the third benefit that I'm not going to be able to demo it all today because we don't have enough time. But the core idea here is that Quarkus is reactive down to the core. So down to its core, like all the core libraries and the HTTP layer and security layer and all that stuff is reactive. So it's non-blocking down to the core, but that doesn't mean that you as a Quarkus user need to use reactive libraries. No, you can use blocking libraries if you want, but if you want to move to full reactive, then all that stuff is there, and it works on with non-blocking IO instead of like worker pools and stuff like that, thread pools and stuff like that. So this is a very big benefit, right? You get to choose. So everything, Quarkus gives you the benefit of having everything reactive. I mean, the runtime benefits of having everything reactive, but you as a developer get to choose whether you want to use reactive or not in your applications, because obviously it comes with a non-trivial complexity. And the fourth benefit, which we consider super important for the adoption from users, is that Quarkus has so many integrations with all the frameworks and libraries that you already use, right? So when you're coming to Quarkus from a Java world, a Java enterprise world, you already know, you already have most of the knowledge you need in order to write a Quarkus application, right? So you don't have to learn APIs from scratch. You don't have to learn a new persistence library. You don't have to learn a new HTTP library with weird annotations or DSLs that you don't know. You don't have to learn a new integration framework like that, right? You can use the stuff you already know. So you have Hibernate, you have REST Easy, which is our JAX-RS layer. You have Apache Camel, all that stuff. You can even use our Spring compatibility layer and continue to use like Spring Web or Spring Data JPA if you don't know, for example, JAX-RS or things like that. And of course, you have integrations. So of course, there's Vertex, which is the foundational layer of all our IO. So you can drop down to the Vertex layer if you want, and there's integrations with all these awesome projects that make up the Java cloud native space. So you have integrations with Kubernetes, OpenShift, Jaeger for tracing, Prometheus for metrics. There's awesome Kafka integration, all that stuff that you as a developer already know, most likely, is already there in Quarkus. So you don't have to spend a ton of time ramping up your knowledge to Quarkus, because most of this stuff you already know, right? So yeah, I mentioned earlier when we were looking at the performance numbers of Quarkus, I mentioned earlier that we're going to talk about real briefly, like how does Quarkus achieve all these awesome numbers, right? They kind of seem too good to be true, but they are true. I can guarantee you that, and you can verify that on your own if you don't believe me. But how do we get these numbers, right? Well, what does Quarkus do so differently than all the stuff, all the frameworks that came before it, right? Well, the idea is that Quarkus aggressively tries to do as much stuff as possible at build time. What does that mean? That means that with your traditional application, right? Let's say a Thorntail application or a Spring Boot application, when you did in the past an MVN package, what that did basically is it would just create a jar, right? And there was like almost zero other activity going on during that build phase. So the Java compiler compiled the classes, and then the Maven plugins would just package them into a jar, ready to go. So there's very little going on. But with Quarkus, we move a ton of stuff into build time. So when you're doing that MVN package or the Gradle build or whatever, then we, instead of like delegating all the heavy lifting of a framework to runtime, we actually do all that stuff at build time. What does that mean, right? In practical terms, that means that we go ahead and scan the entire class path, because at build time we know what the class path is, right? We scan the class path so we can scan all the annotations. We can generate all this extra metadata and meta model objects and classes that are needed in order for these frameworks like Hibernate or Rest Easy, all the stuff that all the extra information that is needed for these frameworks to work properly at runtime. Quarkus can build that information at build time because it has access to all the configuration files. It has access to all the annotation stuff like that. It can create proxies where needed. And not only does this move so much effort to build time from runtime, which in turn means a lot faster startup time and a lot less use of memory, but that also makes the usage of GraalVM so much easier. And because Quarkus has integrations with GraalVM, it can tell, it can assist GraalVM in what, like, let's say needs reflection, because GraalVM doesn't support a reflection out of the box. You need to do something to make it work. But with Quarkus does that for you as part of this build time processing. So the benefits of this thing, right? So the benefits of doing as much as possible at build time are the following. You do the work once, not at every start. So imagine like you have a Quarkus application, Java application that you want to deploy it 100 instances of it, right? With a traditional stack like Thorntail or Wildfly or whatever, then each time you started this application, these 100 different instances, 100 times the framework would need to do all this class path scanning, parsing configuration files, blah, blah, blah. It would need to do it for every startup. But with Quarkus, you do it once at build time, and then the 100 times the application starts, it has this metadata all pre-built and ready to go. And that means that first of all, you don't need all the bootstrap classes that are needed to create all this metadata information. So think, for example, for Hibernate, you would only the XML parsing related classes are only needed to parse like the persistence XML. If your application is not using XML, which most likely won't be, then all this ton of classes that deal with XML are not needed at runtime, and that's a very significant improvement when it comes to memory usage, right? So because the more classes you need, the more memory the JVM needs, the more internal memory the JVM needs. Of course, this also translates into doing a lot less work, right? So when you do a lot less work at build time, then not only are you consuming a lot less memory, but you're doing a lot less work at runtime to start the framework. And that's why the Quarkus applications start so fast. And finally, because you can generate a whole lot of classes and configurations at build time, there is very little or almost no need for reflection or dynamic proxies, which are things that definitely slow down the execution of Java programs at runtime. So I've talked a lot here about this is kind of like a whirlwind tour of what Quarkus is at a very high level and what the benefits are. So I talked about a lot about like, all right, it's really fast and can do this and it can do that. So let's, in the time we have now, trying to do a demo of what this actually looks like in real life. Right, okay, so I'm going to exit here and go to my IDE. So here I have a project that I've pre-generated in order to not waste your time. I've pre-generated a Quarkus application, which you can do from code.quarkus.io is our project generator. You can select a bunch of integrations that we have and extensions. I'm not going to do that now here, but you could either generate a project from here or from our command line tooling. So what I have here is basically I generate a hello world application, right? And I added a couple extensions, which I'll talk about really soon what they do. So let's, this is what it is generated out of the box is just a JAX-RS application. So it's a Quarkus application that uses JAX-RS. And what I'm going to do now, I'm going to start the application. So we use this Quarkus dev mode. So dev mode is basically the embodiment of this developer joy, right? So in dev mode, the application started in 1.3 seconds. In regular mode, it starts a lot faster. but I'll show you that soon. So dev mode, what I would do here is that I would go to localhost 8080 and hello. I must be doing something. Oh yeah, right. I did not write that correctly. So localhost 8080, I get hello. And now I'm going to show you something that in Java usually people aren't used to. So all I do is I change code here and I refresh the browser and I automatically see that that change being reflected. So this is something like Node.js people or Python people are really used to. But in Java, we really didn't have this thing working so well with like zero configuration. I didn't have to configure anything in my IDE. I could have changed this from the command line or any editor or whatever, and it would just work. And of course, it's not limited to these super simple changes, right? It can handle any kind of change. So let's say I want to return JSON, and I'm going to create a object here, and I'm going to say getter greeting resource. And let's say here I'm going to return greeting, and it's going to be media type application JSON. And I'm going to say new greeting, hello world. Right. So once I refresh this automatically gets updated. So all the changes I made are automatically reflected so quickly. I mean, I don't even understand that the framework's restarting and doing all this extra build time stuff. It just works, right? And of course, it's not. I can do more stuff than that. I can, let's say, I can add a configuration property and see what that looks like. Updating that looks like. So I would go greeting resource here. I'll do string message. So let's say I wanted to move the message into like a configuration property, config property. I'm going to use a micro profile config here. So I'm going to do greeting message, and I'm going to say message. Excuse me, this is called name, right? And if I say hi, folks, and I refresh, then I automatically get that. So you can see where I'm going with this, right? Like I can keep on making whatever change I want, never have to restart the framework. Then I just make code changes, they're reflected, and life is awesome, right? So let's see now if I want to create the actual jar, right? So I'll go mvn package. I'm going to skip the test for now. Don't do this in production. Don't do this in your normal day, but I'm going to do it now to keep things fast. Package skip tests. And now I'm going to execute the jar by saying Quarkus Kubernetes demo runner jar. So the runner jar started for me in 0.751 seconds. So under a second easily with all this stuff I have. And of course, if I hit it here, it just works. Right. So that's the jar, but I can also, if I want, I can compile this down to a native image. And a native image, I can compile it by just adding one extra flag, right? I enable a Maven profile, the native profile, and we'll see this will take like maybe a minute or two to create the GraalVM. Via GraalVM, it's taking our jar and converting it to a Linux binary. So I'm running Linux here. This will convert it down to a Linux binary that I'll start, and you'll see how amazingly fast it'll start. This will take, let's say, maybe a minute on my machine. Probably less though. So what's going on now is that GraalVM is looking through all your code, and it's eliminating as much extra code. So going through all your code, all your libraries, the JDK, everything, and it's going to create a binary that only has the stuff, the code that was actually reachable, right? So it doesn't contain everything. That's why it's so it'll start so fast. And now if I go, sorry, let's go here. Target, see what was created in the target directory. So we have this runner here, right? So this is a Linux executable, and its size is 33 megabyte, but that's not the impressive part. The impressive part is how fast it will start. right? So Quarkus Kubernetes demo runner, it started in 16 milliseconds, right? So that's just amazing. And I think I also have a PSRSS Quarkus. So what I'm going to show here, sorry, grep. So right, this application that's running now is taking 30 megabyte, right? So imagine that. That's a Java application that when I run it takes like 35 megabytes. So it's a hello world, right? Obviously, right? But if I could use Hibernate here, and again, the numbers would be really, really low. So this is pretty much unheard of in the Java world. Um, to be able to use all these amazing frameworks, keep your excellent productivity, but have such amazing runtime characteristics. So that concludes, let's say, the short coding part of what I. So I obviously didn't code much here, right? We could go on and continue and add a ton of features with Hibernate, with Kafka, with anything you can imagine, because our Quarkus extension ecosystem has like over 200 extensions. So there's so much stuff to choose from, but we have so little time here. So that the other part I wanted to move on to is to show you how with Quarkus I can deploy my application to Kubernetes so easily, right? So for the folks of you who have wanted to play with Kubernetes, but you're always like, whoa, what's going on? There's so much stuff here. I don't even know where to start. Or the folks that have played with Kubernetes, but have seen like how difficult it is to configure things, to make to write all this YAML and use all this tooling. It's difficult, right? So what we wanted to do here with Quarkus is make things super simple when you want to actually take your application and deploy it to Kubernetes. So I have a Kubernetes cluster here. This is OpenShift, so it's basically Red Hat's distribution of Kubernetes. And I'm using OpenShift here because OpenShift gives me like this, among so many other things, it gives me this awesome console here that I'll be able to use to show you the application running. So basically what do we have here, right? We have, I added two extensions, the Kubernetes extension and the container image gib extension. What the Kubernetes extension does is it will create all the Kubernetes manifests, so all the Kubernetes YAML files that I need to actually deploy the application, and it will take and apply those YAMLs to the Kubernetes cluster. What the container image gib extension will do is that it will create a container image for me and push it to a registry so that then that container image can be used to run the Kubernetes pods. So let's see how I can actually deploy this application onto Kubernetes. So all I'm going to do is package. So just like I did before, I'm going to skip the tests, and then I'm going to add one flag, right? So Quarkus Kubernetes deploy equals true. And I'm going to do this, but I'm also going to show you that I've added two more things. Basically, I've added which container image registry I'm going to push to. So this could be Docker.io, but I'm using Quay here. And I'm going to choose the username under which I push this image. So this is mine. It doesn't need the credentials because it finds them automatically. And I'm because my Kubernetes cluster is not using a valid HTTPS certificate, I'm going to trust the certificates. So just executing this command, package, skip test, Quarkus Kubernetes deploy true, will do the following things. It will create the jar for me, like the jar we saw earlier that we built. Then it will use gib, which is a library to create container images in Java. It will use gib to create the container image and push that to Quay. And then it will Quarkus will create the Kubernetes YAMLs and apply them to the cluster. So you can see this helpful message here that told me that it applied the application to the cluster. And I can immediately see here that in Quarkus, in my OpenShift console, that I have this deployment, the Kubernetes deployment ready. If I go into it, and I see the pods, I see that I have one pod running. It's taking up only 83 megabyte of memory so far. And here's the log where this application started. So you saw that when I ran it locally, took like 0.7 seconds or something like that. But on this cluster, which is very, very slow, this is a very, very slow cluster, it took a significantly more amount of time. So this is like a test cluster with very limited resource. So that's why it takes 4 point something seconds. But nonetheless, what I wanted to show you is how easy it was to deploy this, right? And with OpenShift, we can expose this application to the Quarkus Kubernetes, to the internet. Quarkus Kubernetes demo, select a service, and this is how we're going to expose it. And also, here's my application. All right, remember I hit it the hello world endpoint, and I got exactly what I had locally. So you saw, right, that with one command, basically, package and Quarkus Kubernetes deploy true, I was able to take my application from my machine and push it onto the Kubernetes cluster. And the magic here is that we've created this Kubernetes YAML file that contains all the Kubernetes stuff, and we've pushed the image to Quay. So by the time that we apply this YAML file to the Kubernetes cluster, this container image has already been pushed to Quay. And with Quarkus, there's a ton of configuration you can make through properties to this configuration file. So if, for example, you can change all these names, labels, you can add by adding like a metrics extension, you could add the proper annotations for Prometheus to work. By adding the health check extension, you would have health checks here and all the good stuff. So just by adding extensions and configuration, you can infinitely configure this this Kubernetes deployment as well. And I think that basically, yeah, that's all I had for you today. And just I'll leave this slide here is for where you could reach us. Quarkus.io is our website. Then we have a chat, which is a Quarkus.io Zulip chat. And of course, you can reach us on Twitter. There's a mailing list and stuff like that. So any questions you have, just feel free to reach out. We're very active on all these channels and try to help out as much as possible. So that's all I had, and I sincerely hope that I was able to get some to transfer some of my excitement, enthusiasm about Quarkus to you. For those who have not tried it out, I really hope you do. And for those of you who really want to learn more about the magic of Quarkus, Stuart has a talk in a little while. So thank you very much. I think I'm going to stop sharing now.
Thank you, Georgios.
Thank you. Thank you for
very interesting session. Maybe we have time for one question from the audience. If anyone has a question, now's the time.
Excellent.
But I don't see any question yet.
Okay. Well, like I said, feel free to reach out to me or like any of the Quarkus channels later on for any questions you have. We'd be happy to help you out.
Okay, so I guess this is it. Thank you again, Georgios, and see you around.
Great. Thank you. Thank you, Marco. See you.